Okay. What we're eventually going to do is look at what the hell. Right, going to look at that. Okay, which is a kind of cross-reference of how we are dealing with each other. We're talking about whether somebody's listening to the words, whether you're listening to the object of thought, what we're trying to focus on in an abstract or astral sense, or you're listening to, attending to why I'm talking, the shape that I am, almost like the structure of my being, such that when I produce words, why is it that I produce that? So some people might be thinking, oh, it's quite intuitive, because you can tell I'm just making it up as I go along. I haven't cogitated, thought of the words, and are literally saying the words carefully because I've thought of exactly the words I'm going to say. So it's to do with that and just the physical beingness of us. Okay, so there are four kind of different layers, and how I that people might be familiar with this from whatever background you've got, whether it's skandhas in Buddhism or chakras or emergent levels of biological and more complex systems of our being. It doesn't really matter what your background is regarding that construct, but you know that you're made up of layers or levels of complexity, and we are going to derive that in a mathematical way. Okay? And now, I don't know if this is going to be a metaphor or not. Now, the basis, and I'm going to probably put this in another space, is to do with, okay, I think you might be able to see it from that perspective. It is to do with e to the pi I. Okay, and this layer down here is the construction of e to the pi I. So basically, the only ones we're going to look at from here this way. So what happens is e to the pi I is a beautiful equation or formulation or identity by Euler, and it's e to the pi I is equal to negative 1. E to the pi I is equal to negative 1. Actually, it's down here. Oh, you can't quite see it. There it is down there. Actually, let me just do this. Turn this down to the side there. Can you see that? Right. E to the pi I is equal to negative 1. Now, traditionally, the reason, that mathematical formulation, which is to do with using blending coordinate system with pure maths or number theory, and I think it was Gauss, but it could have been somebody else. Riemann? Actually, I'm not sure. I've lost track. But e to the pi I, Euler managed to kind of constrain, or it's almost like the equivalent of E equals mc squared. Okay, E equals mc squared is related to physical reality. It's a bizarre kind of way. Okay, the fact that there's any correlation of any of the maths to physical reality, Einstein was completely perplexed by. Well, we're looking at the reflexive side of this. So when we get this pure mathematical form, which is e to the pi I is equal to negative 1, or e to the pi I plus 1 is equal to 0, it is a very elegant way to combine different aspects of mathematics. However, the classical interpretation of that is physical. So we're talking about literally a physical coordinate system, and numbers refer to, for example, measurements on a line. However, we've used this mathematical system to, over maybe 100 years ago, 150 years ago, to mathematize electromagnetic fields. Now, electromagnetic fields are a bit tricky. Okay, so you're looking at them right now on the screen, and they're operating within the computer or whatever phone or device you're using. Is banding around from wherever your device is to through the internet to satellites and bouncing around all over computers. Right, electromagnetic fields are in operation there. The mathematics for that is basically all based, a bit weird, but on e to the pi I is equal to negative 1. That is something to do with relating the multiplication by negative 1 or to the square root of negative 1 to derive a different dimension. So, okay, you don't have to know all that. I'm just kind of waffling here slightly. All right, so here we go. This is basically a circle, and it's a unit circle. So the distance between 0 and that point there, where the circle hits the x-axis, is 1. So e to the pi I is equal to, there, -1. Okay, e to the 2 pi I is equal to 1. Okay, and so what it actually means is e, which happens to be a constant, which is it's way over here. E is equal to 1 plus 1 over n to the power of n. Okay. Do we want to look? We're not going to go into that. The point is e, which is a concept in mathematics to do with logarithms. Okay, the exponential function that when you integrate or differentiate, it remains the same. That is actually a very interesting property. Okay, so it relates exponentials to logarithms, and it changes multiplication into addition. That's the kind of useful mathematical pure use of it. It changes multiplication to addition or addition to multiplication. Okay, so which is quite interesting if you're into pure maths. Okay, so it transforms functions or the operations. Regardless of that, the point is e is a constant. There's something about e being very special. And it happens to be a constant of 2.76 or 67 or whatever it is. But the bizarre thing is this, transcendental number, it goes on for infinity, 2.76, whatever it is, all right, to the power of I, which is the square root of -1, which is a little bit odd, all right, and you multiply 2 to the I and the angle, okay, the angle round here, so e to the pi I, so for example, that is e to the pi alpha, it's just a point there, that's its point right there, e to the I multiplied by beta, a different kind of angle, that would be there, different kind of angle, and so on and so forth. Okay, so the angle going round here defines, so when it's e to the 0 I, that's 1, because e to the 0 is 1, all right, because anything to the 0 is 1. Okay, so but when we increase the angle, e to the pi divided by 2 will be a quarter circle, and e to the pi, that means pi radians, 3.4 radians round. That means 3 times the length of your radius, 3 times that, 3.14, whatever, you get a transcendental number, times that gives you the length along there, and eventually you get to that point there. Okay, so 3 e to the pi I gets you there, and then it's 3/4 and so on. Now, another way, actually a very neat, convenient way to just package, while we're at it, okay, don't know if you can see it there, yes you can see it over there. There's a guy called, Michael Hartle, and he's basically emphasizing the Tau Manifesto. Okay, he's basically saying that pi is not the appropriate constant we should be using all the time, and he says it should be 2 pi. Because if you look at equations in electromagnetics and various other places, lots of places, basically it's always about to do with 2 pi. Why? Because we're interested in the whole circle. And so 2 pi is equal to the whole circle. So we learn in schools, for example, that circumference is equal to pi d. Okay, so we're relating the diameter to the total. Whereas what he's saying is it should be tau r. Okay, not 2 pi r, we have to multiply the radius by 2, and then you get the circumference. What he's saying is there's a direct relationship between the radius of a circle and the whole circumference. Okay, and that is 2 pi, or a better way of doing it is tau. And it means then that you can actually say that's half of tau, that is a quarter of tau, 1/6 of tau, and so on and so forth. Basically, it just makes more sense. Okay, I'm not going to go into it, but if you're getting kind of worried about, well, pi, why is it over there? Forget about that. Just think about tau as being a complete circle. Now, the reason why I'm recording this, and 9 minutes in, and I'm giving you the purpose of why we're actually going to do this, is because I've kind of formulated all this over the last couple of weeks, and I'm just wanting to share with this, and I just want to record this so that if anybody ever follows this, I've done it. Okay, and hopefully it'll be helpful to you so that you can actually complete the next step. I'm getting close. I'm getting close to something, and I need to kind of verbalize it and maybe record it just in case, I get growth from the kids and, die. Okay, so e to the pi I. So something to do, right, so what I'm saying is that e to the pi I is equal to -1, or e to the tau I is equal to 1, is a complete circle, is oneness. Now, I've been playing with oneness. I've been talking about roots of unity, okay, talking about 1 to the n. So you're listening to this now, and if there's n people listening, 1 to the n of us are listening well. Now, it's to do with listening and how we are identifying ourselves and what we're listening to. Is it the words? Is it the concepts I'm talking about? Pi, I, all that kind of bonks. Or are we talking about the being doing the maths? Ooh, and that's disposition, okay? And then we're into the level of, how does any of this actually make any sense in our meat bodies and our brains and our neurons and so on and so forth? And how we make sense of absolutely anything. And the fact that we actually have physical bodies. Okay, so how are we listening? Are you thinking about me as a complete separate object? We have a problem. If you think about the words that I'm using, that's not so good either. If you're trying to follow the thought line, you go, oh, that's pretty good. But hopefully we're going to get to the point where actually the people that are listening, we understand that it's actually the third level, the resonance of being. Okay, how I am talking, how you are listening, and it's in the receptive state. I'm going to derive that from the maths. So I'm interpreting e to the tau I is equal to 1 as another form of mathematical expression to indicate unity. Because it is. E to the tau I is equal to 1. It's that. And the graphic form of it, through conventional mathematics, is a circle. Okay? And so that means that the angle around there, is a bit like time. So what happens is you don't understand something or other, a person is rabbiting on, they rabbit on for a while, and they say quite a lot of stuff, and eventually, some part of you go, oh, that's what he's talking about. Okay, now that happens in microseconds. Okay, microseconds, there are, for example, the words. So, oh, that's one word. Oh, okay, that's another word. Oh, that's another word. And then there's a few of these words. Okay, that might be one word, second word, third word. Oh, I know, it's a phrase. I'm following the phrase. But your consciousness is not really paying attention to that. It's not going, oh, one word. It's not doing that. But if it is doing that, well, those people who have listened in that way have fucked off. Okay, they are no longer with us. Okay, if they're listening in that way. Okay, so there's a longer wave. Okay, there's a longer wave, and that's how words compress into semantic units, and so thoughts can be expressed using these semantic units. Okay, semantic units, I'm not going to start, right. But let's just go for, okay, so it's basically a period of time. So instead of thinking about this as being a spatial circle, it's actually a temporal condition. Okay, so the beginning of the sentence began a little while ago, and at some point or other, it's going to end. The beginning of this sentence began, and at some point in the future, it ends. And you go, oh, right, okay, so it's a complete sentence. It's a phrase, and perhaps it has meaning. Okay, so it's a temporal. So when we do a turn of thought, okay, it means time has occurred. And once we get that aha moment, and you will get that aha moment at some point, okay, you're going to go, aha, that's what he's talking about. Okay. And that'll be a period of time. Now, I've been yapping for, we're into 13 minutes, and I don't know, you're kind of starting to get into sync with how I'm talking, I hope. Okay, everybody that is persisting with this and got to this point is definitely persisting, and you're definitely in some form of sync. Okay, so now another way to represent this, again, completely traditionally with mathematics, is using the sine and the cos wave. Okay, so what happens is that, so for example, e to the pi alpha, that point right there, has got an x and a y coordinate. That x coordinate can be mapped, and you put it into, well, actually in this case, the y coordinate. Okay, now that's time now, or in fact the angle. So when the angle is that amount, we've just started, the length of that is there. Okay, so when we go to the next one, if we kind of like carried on and we got to quarter of the way through the sentence, a little bit further the way than the sentence, that would be e to the I beta, it's just gone that little bit on the x-axis and quite high on the y. That little bit on the x-axis is that little bit. Okay? And the next one, when it keeps on going, we're past the halfway of the sentence, and then a little bit later we're there, alpha, beta, gamma, e to the I gamma, that point there, it's quite long. We've gone quite along in the x-axis, and that's quite long after on the vertical axis. So we're mapping, and this is what mathematicians do all the time. Okay, so what happens is this angle, okay, is now measured along the way, linearly, and this represents how far it is away from the y-axis. Okay, so it's actually the distance of the x-axis. So at the beginning, it is 1. It reduces until eventually it's nothing. It's right there. That's there. And it continues going on. It expands and expands and expands until it's quite long. All right, that's another quite long x bit. That's that point there. And then it shortens until eventually it's there, and there's no distance on the x-axis. That's there. Until eventually it keeps on going until we get to there, and then the x-axis, the point extends along the x-axis. That's there, up there. So this is another spatial. Okay, and the people that can do this are pure mathematicians, maybe engineers and physicists and so on and so forth. And it's all spatial. All of this is spatial because basically, fundamentally, it's based on numbers. Numbers usually relate to counting things. So even though what mathematicians do is they start going, well, who cares about the things? And they just start talking about patterns of numbers and relationships and so on and so forth. And they get to this kind of level of maths, which happens to correlate in some way or other. They've managed to correlate it to electromagnetic waves. Okay, now we're not interested in that. We're interested in a sentence and an aha moment. Okay, we're interested in a word. And we go, oh, the word, another word, another word. Oh, a phrase. So the cause wave happens to correlate to how far away along we are in this x-axis. And what is the x-axis? What does that mean? So there's some kind of transformation that's going on as we are listening to anybody. Okay, and it's happening in the moment. And the time progresses, and somehow our minds change over that process. Okay, it's trying to make sense of the meaning. Somebody's warbling away. Okay, I'm not quite sure what they're talking about. Oh yeah, I do know what they're talking about. Okay, great. Now, it might not look like that. Okay, it might not look like that curve. I'm just suggesting a mapping of this. Okay, that if we think about this as being a thought, okay, and getting to a complete thought and so on and so forth, we could measure it in terms of time. Okay, so we start getting a measure of time. And of course you have spent time, around 17 minutes, okay? And so there's a certain amount of time as we're going along through here, and we're like, okay, I kind of know you're talking about maths. Any mathematician's going, yeah, he's talking about maths, but what the hell is he talking about? And hopefully it'll merge back into, oh, okay, he's talking about maths again. Or somebody else is listening to this going, okay, I'm interested because somebody recommended that it was talking about human beings, and what the hell is he talking about? And oh, he's talking about human beings again. Okay. So, okay, if this is a measure, it means, and this is the great difficulty I've had, okay, over the years, is where's the measure? I haven't been able to. With physical objects, it's easy. 1 pen, 2 pens, 3 pens, and so on and so forth. It started with sheep, most probably, okay, and then it measures into, measurements of how much oil, how many how many urns of oil we managed to extract, how many bundles of corn in Egypt or Sumeria, wherever it is, okay, and then we had numbers, and then we had astronomy, and numbers, again, it was of things, okay, measurements of things, but we're not interested in measurements of things. But the whole basis of mathematics is kind of based on things. Okay, measurements, mathematics, and it's the measure. Patterns, okay, of measure. But when we're talking about time and us and consciousness and subconscious or preconscious and all those words, okay, what I'm saying is that there is a way potentially of using this mathematics to reflect upon our psychosocial state. So, let's just go on with this, all right? So let's say that we have, see this blue in here, we have, I've presented some kind of concept or thought or Okay, in the traditional form, it would be something like Socrates is Greek. Okay, all Greeks are philosophers. Okay, therefore, Socrates is a philosopher. Okay, now that is sequential, and I call it post-conscious thought. And that's what Western society, philosophy, maths, everything is about. What I'm interested in is you say something and you're like, oh, okay. Then you're into the second one, and you're like, okay. And then you're into the third one, and it's not a conclusion. It's more like, if you keep that in your head, you keep that in your head, you keep that in your head, oh, there's something at a longer temporal sequence that goes, at that moment you can get. Aha. So the way I teach algebra is like that. I say, you've got an equal sign, that's like the law, you can't break that, although you can have inequalities. All right, but that's the law, you cannot break the equal sign. Second one is you're looking for, what are you looking for? And it's the unknown. If there's an x somewhere in there, you want x by itself, on one side an equal sign, and whatever's on the other side, it's a number, hopefully that's your answer. Okay, and if you obey the equal sign, and you're looking for x, great, okay? But the third thing you've got to do is usually have a big ugly expression. Like that, or something. And the idea is that you want to simplify it so you have x, because you're aiming for x by itself. So you've got this big ugly equation and you're trying to get to nice something elegant. How do you do that? You get rid of stuff. Quite careful, not subtract, you get rid of stuff. You're looking at it and then you're trying to extract that x. So you've got to get rid of stuff and usually use the inverse function. Use things furthest away from the x and the inverse function. And in that way, you're kind of reducing, taking things away until eventually you end up with x. Now, those are the three functions. 1, 2, 3. Now, if you do all those three at the same time, that's algebra. It's not a conclusion, it's something that you do. So you do this, you do this, you do this, you do this, you do equal sign, you make sure you keep on aiming for the x, you keep on getting rid of stuff. Oh, I've got the answer. I'm doing algebra. Right. So similarly, there are processes going on here which is like that. Now, as an aside, I think that's related to Fourier transforms. Okay, I don't know enough about Fourier transforms. I find it tricky. The mathematics is quite high level, but effectively it's a superimposition of waves, wave functions, and being able to superimpose them, and it creates a complex Fourier wave. And you can actually look at a wave and break it down into its various components. You can go to inverse Fourier, I'm not sure. Okay, and that is basically the standing wave of our consciousness. And we're doing that with letters, not really letters. We're doing it with sounds and syllables. We're doing it, composing into words, but we're not really when we're listening, thinking about words. And we're composing thoughts, wherever that is, in some kind of weird abstract space. And somehow or other meaning is conveyed or constructed. Okay, all that kind of mystery. I think that is actually, this is the root to it, is the Fourier transforms, if we're thinking about it in this kind of way. Now, which means that the people that are sitting there doing AI and so on and so forth are playing around with these kinds of mathematics, but they're not quite aware, I don't think, of the fact that that's actually what's happening. They're just using mathematics to simulate, okay? They don't really know why it is that Fourier transforms actually apply to thinking processes. Okay, so maybe they do. And if they're watching this, they're like, oh yeah, that's I know this already. Oh, great, fantastic. However, I'm more interested in the social, not producing AI, but producing social cohesion. That's the tricky bit, right? So we've got these waves, okay, and basically it means you're going from one state. Now remember, we're in second order thinking, all times. Existence is happening at velocity. There is no stillness. You're thinking, you're living, you're breathing. It's a second order process already, okay? There is no staticness to our existence. So, similarly, you very seldomly start off like with nothing and then you have a thought. Okay, it's, you've got a thought or a feeling or something, and here's another one. And in fact, it's usually superimposition of thought after thought after thought, and then another feeling and a thought, and so on and so forth. We might be able to maintain our focus on one thought, and that gives us the illusion of stillness, but actually that's a thought. Okay. But it's to do with volume of thought and whether somebody's shouting or somebody's actually, not saying anything and you're just sensitive to the thought or the feeling's very painful, and then more subtle thought feelings. So eventually they're so fine and you're in a mountain cave, and there's no sound whatsoever, there's no sound, there's no thought, and then there's kind of feelings have abated, so that it really is refined, and you get this incredibly refined amplitude of existence. Okay. We're not there. Okay, we're not trying to get there. We're just trying to interact in a social sense. Now, then what I've done is I've tried to go, well, which aspects, because if you look at some of the other work, and if you have, then this will make more sense, it's to do with time, where we are in time. And when we hear something, we go through this process. And the process is, if this is the beginning of our listening, and that's kind of like, oh, I know what he's talking about. It's very, very similar to seeing something like a spire or a mountain. You see a spire, in the distance. Now, you don't know it's a spire. It's just an object. Okay, it happens to be a spire. Okay, that, privately, objectively, in actuality, it's actually a spire. Okay, it's on a church. However, we don't know that. It's just, we're driving along, we just see this thing, we're like, what's that? The fact is, we say, what's that? Okay, the fact that we've spotted it, something, light is going into our eyeball, okay, and it's trying to make sense of it. It's an object of some kind. We can't work out what the object is. It doesn't fit into it, but we do know it's an object of some kind, so we say, what's that? Okay, but maybe we'll go, oh, I know what it is. Oh, wait a minute. That's this point. But before you know what it